Good morning. So one thing I wanted to start with today is at the end of notes 503. We did skip the very last proof, proof number 5. So I do want to come back to that here. So again, the back of notes 503, proof number 5. So if you want to pause to find this page, something I'm going to discuss here is this quadrilateral ABCD was graphed with those 4 coordinates. So again, if you don't have a graph, please pause and graph it with me. But counting our slopes, again, these horizontal lines I found have kind of confused some students. So remember, your slope is a rise over a run. So from A to B, we rise nothing. We run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We run 11 boxes. So what that tells you is that the distance of A to B is 11. And that's just a nice counting case because it goes straight across. Okay. When we have to use our Pythagorean theorem or our distance formula, okay, so remember distance equals the square root of the A squared plus B squared we've been using. That's when you're looking at a diagonal here. And I'll talk about that with AD in a minute. But C to D, same case. Rise is 0, it runs 11. Okay. BC, from here, I'm going to start at C at the bottom. If you do BC, you have to go down and to the right. Then I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, up, left 2 equals 9 over negative 2. Now, when we go to find the distance of B to C, if we needed that, the distance of BC, that's where we use these digits into that radical. Because BC, if I kind of sketch in our right triangle here, it's up 9 squared over 2 squared. A squared plus B squared equals C squared. So we get 2 squared plus 9 squared gives you 81 plus 4 more is going to be the square root of 85. Okay? So that's how we use our digits into our distance formula to find the distance, if we needed it. Okay? Depends on what you're asked to prove and if you need it or not. Last but not least, AD. Again, I'm going to go down from A and over to D. So a lot of students have been drawing the box around your figure, and I'm going to show you that with another example. 9 down and 2 across. So that slope is negative 9 over 2. So the distance from A to D would be the square root of 9 squared plus 2 squared. Now, if we even put a negative 2 in there, or the negative 9, remember, negative squared become positives. That's going to give us, again, the square root of 85. Now, the square root of 85 is definitely not 11. So we know that these sides, AB and AD, are definitely of different measures. Okay? So again, on that A squared, B squared, C squared, we found this side here to be the square root of 85. And this other side of the parallelogram to be the square root of 85. Okay? So here we have the 4 sides. DC, I forgot to put in, is also 11 boxes across. So when you're asked to prove a parallelogram, but not a rhombus or a rectangle, so again, looking here, if we want a parallelogram, but not a rhombus or a rectangle, the not a rhombus idea is a rhombus has 4 equal sides. So remember, a rhombus has 4 equal sides. Okay? So by finding those 4 distances, again, distance of CD was 11, okay? By finding the 4 distances, you proved that it doesn't have 4 equal sides. So that's where your distance formulas can kind of help you here. Some other work I showed right here is diagonal AC and diagonal BD. If you found those slopes, that also proves you're not a rhombus because the diagonals of a rhombus should be perpendicular. But most of you, again, remember that it has 4 equal sides. So using your slopes to help find your distances, I think is going to be an easy case. So looking at the conclusions for this one, I have written here, we did have 2 sets of parallel sides, which gives us a parallelogram. Okay? But the not a rhombus idea, since I just found the distances, we're going to need a conclusion to say ABCD is not a rhombus because not all sides are equal. But it also asked, nor a rectangle. So we need a little bit more information about the rectangle piece, and that's where these slopes help us. AB and BC, for this to be a rectangle, AB and BC should be making a right angle here. And these two slopes are not negative reciprocals. So that's what this statement I just kind of skipped over says. AB is not perpendicular to BC, and also the diagonals were not perpendicular, because slopes are not perpendicular or negative reciprocals. So that gives you the fact that it's not a rectangle. Okay? So that's what we have here for proof 5 from our notes. So this I did skip over in the last video where we skipped it in class. So if you wanted to come back to this to see what was necessary. I do also on the back of the classwork, again, my apologies here for triangle Jen. I noticed it did go off the grid a little bit, so sorry about that. Your slopes should have been those negative reciprocals, -3/2 and 2/3, or the 6/4 and the 4/6 to be perpendicular. But when you're finding your distances, you use the original measurements. So that's just one thing I want to say. For those of you who were finding your distances to prove it was isosceles, you want to be using the original measurements. If you use the reduced formats, you're actually shortening your line because you're not finding the whole length. You're only finding half of it if you reduced your fractions by a half. Okay. But the proof number 3 on the back is one that I know some of you were missing the mark on or skipped. So to prove JKLM is a parallelogram, you need 4 sides to be parallel to each other, or the not a rhombus, you need the diagonals here. Okay, so if you found the slope of all 4 sides and the diagonals, that's going to prove that you have 2 sets of parallel sides. And to be not a rhombus, you're going to prove that these diagonals are not perpendicular. So your conclusion here would have been that JL is not perpendicular to MK. So that negation, changing it to a not case instead of an is case, I think was confusing for some of you. Because again, slopes are not negative reciprocals. Okay? So that math is what you really needed to have stated here. And then you should have had one more conclusion to tell us it's a parallelogram because 2 sets of opposite sides are parallel. So you would have had a conclusion here that JM is parallel to LK and ML is parallel to JK because slopes are equal. And then you would have had one more conclusion to call it a parallelogram, but not a rhombus because only opposite sides are parallel, diagonals are not congruent. So there would have been a longer statement here. But I found some students were drawing in this big box. So I want to explain that because it helped a lot of students in class yesterday, and I wanted to speak to that here. Up 3 over 6, over 4 down 6, down 3 over 6, and over 4 up 6. We need that idea when we are doing our area formulas. Okay, so back to notes 501. But those digits help with our distance formulas. Okay, so if I found the distance of all 4 sides, so if I didn't use slope and instead, this is a big or, I use the distance formula, okay, the distance of JM equals the square root of 3 squared plus 6 squared. So again, that a squared b squared to give me c squared is 9, and 36 gives us the square root of 45. Then I would find ML. The distance from M to L is the square root of over 4 down 6 is 4 squared plus 6 squared is going to be 16 plus 36 will give us the square root of 52. Then we have the distance of LK is down 3 over 6. 3 squared plus 6 squared, again, is the square root of 45. And then the last one, J to K, is the square root of 6 squared plus 4 squared, again, is the square root of 52. So, oops, sorry, you couldn't see that there at the bottom of my screen. But finding the distances of all 4 sides using those boxes, okay, those little right triangles outside your picture, okay, proves that this has 2 sets of equal sides, but not all sides are equal. So again, to prove a parallelogram, but not a rhombus, we could conclude here that 2 sets of sides are equal because lengths are equal. And then you would say JKLM is a parallelogram because opposite sides are equal and it's not a rhombus because not all sides are equal. So in this case, you could have chosen your own adventure, and that's what the page 5.03, like the concluding statements, kind of tell you. You could be using slope here, the rise and the runs, to prove the opposite sides are parallel. You would have also needed the diagonals to talk about they're not perpendicular, and that helps you with the rhombus idea. Down here, the distances of all 4 sides proves you to be a parallelogram with opposite sides being equal, but not a rhombus because 40 square root of 45, square root of 52, square root of 45, square root of 52 are not all equal to each other.